Hey there, it's that coding guy here. In this video, I'd like to talk about comparison operators and then dive into using those for if statements, otherwise known as conditionals or decisions. So we've previously covered arithmetic operators. If you need a refresher on those, go check out the previous video there. This is W3 Schools, and this is a pretty handy reference. I'll scroll down here to the comparison operators, and probably seems pretty familiar from doing some simple mathematics. We've got operators for equal to. Remember, a single equal sign in Java is the assignment operator, and that's when we're assigning the value on the right side of the equal sign to the variable name on the left. We use that single equal sign operator. So to use equality and check equality on primitive types, we can use the double equal sign. The exclamation point in many programming languages is thought of as not, or the inverse of. So when we combine a single exclamation point with a single equal sign, this is the not equal operator. So we could check if one value is not equal to another value. And then, of course, we've got greater than or equal to, and less than or equal to. So over here in Java, I've got a few variables laid out to help us play around with some things. I've got an integer variable called target temp, as in target temperature, set to 400. And we're going to be talking Fahrenheit. That's what I'm most familiar with. We've also got an integer called current temp, and that's set to 250. And then I've made a couple of strings here to kind of track our statuses. I'm thinking about maybe we're preheating an oven, okay? And if we need to be heating up still, then our status is going to be increasing the temperature. And if we've already met the temperature, we really don't need to go too high. We just need to maintain the current temperature that we're at. So one of the first things to think about and understand when we're talking about conditionals and using those comparison operators is that when we string a couple of these together, when we string together our current temp with an operator and have another value on the right-hand side, we've built something that we call an expression. And an expression is a special type of statement. Like, this is a special type of statement right here. We talked about a little of this in a previous video, I believe, where this is actually declaring and initializing this variable. It's a special kind of statement. This is a special kind of statement called an expression, because it's one value, an operator, and another value. It's basically a verb almost, right? Well, this is an action we're going to take, and this evaluates down to a value. And it evaluates down to true or false. It can't be anything other than true or false. Either the current temp is less than the target temp, or it's not. Okay? With the way this is currently written. So we're going to get a true or false out of this. Is the current temp less than the target temp? I believe it is. So now if we run this program, we get the result of true. And so if we had said the current temp is greater than target temp, what do you expect to see now in our output? I think we're going to get false. All right. And similarly, if we use some of those other comparison operators we just took a look at, we're going to get different results based on whether they're true or not. The current temp is not equal to the target temp. So now that we have this, that opens the door to if statements and conditionals or decisions. And these are one of the basic building blocks of something that we call control flow in programming. We said that Java is executed top down. Here, line 6 is executed before line 7 is executed. Control flow, there are several different tools in our tool belt for control flow, and that's going to help us change potentially the direction of the program based on some decision that we take. So what I'd like to do now is build a basic logic for what an oven might do to increase its temperature, right? So I'm going to say, and this is how to define an if statement. We actually use the word if, and then we have parentheses. In here is where our evaluation is going to go. It's what we want to check. So I want to check if the current temperature is less than or equal to my target temperature. So that's basically what we had above. I said less than or equal to the target temp. All right. Now we open a curly bracket, and if I just hit enter, IntelliJ puts the closing one here. We haven't really messed with brackets too much here, or braces. So one of the cool things about this now that we're talking about it is when I put my cursor on one and click, it highlights yellow, and then its partner is highlighted in yellow. So we can see that this curly brace down here closes this curly brace, and that creates a block of code. And similarly, this curly brace opens this block of code here, and this curly brace is its partner and closes it. So when we do an if statement like this, we can define an entire block of code. And that entire block, or it could be just one line. It can be as much code as we want to put here, okay? And the trick is, this code is only going to execute when this expression evaluates to true. So the way to think about this is if this evaluates to true, then run the code here, okay? So if the current temperature is less than or equal to, then I want to system out heating. All right. So let's just remove this line of code real quick and take a look at our logic here. If the current temp is less than or equal to the target temp, I want to say heating, which is increasing temperature. So I think when we run this code now, we're going to get increasing temperature printed out. So, no matter what our temperature is here, if we come in, okay, now the temperature has heated up and the current temperature is 300. Well, we haven't met 400 yet, so we need to keep going. We need to keep increasing the temperature. And then what do you think we'll get if we're at 399? Okay. We're increasing temperature still. What if we get to 400? We're still increasing temperature here, actually. So I think I've probably got a bug in my logic here, because if we're at 400, I don't actually want to keep increasing the temperature. So what we can do is knock this equal sign off. And so now we're only going to increase temperature when the current temp is less than. It's strictly less than the target temp. So now if we run this, we don't get any output at all. And that's because now this is evaluating to false. And the code that is inside here will not be executed. So this is a basic concept kicking off our understanding of control flow. We have, in essence, allowed the program to skip over this line completely based on the expression and how this evaluates. So we've made a decision here. This is also known as a conditional. So, and we could chain these together too. So we could say if the current temp is equal to, remember we said one equal sign is the assignment operator. It's the double equal sign that is going to be our equal to. If the current temp is equal to the target temp, we'll open another block of code. And now we can use our maintaining string here. So we could do another sout and print out maintaining. And so with this logic the way it is, I'm thinking we're going to get output again. What do you think? Let's give it a whirl. Great. So because our target temp and our current temp are the same, this gets executed, but this does not. But it's important to note that all of these lines were, execution went through all of these lines. It's just that this evaluated to false, so it did not go in here at all. And there's a tool that can help us see some of that stuff. We'll dig into that in a further video. So use these operators here. You've got the greater than, the equal, less than, and less than equal, the not equal. We didn't really talk about that one. So we could say, if the target temp is not equal to the current temp, we could do something else. We can also combine different things. We could check for more than one thing in an if statement too, using some logical operators that we'll talk about in a little while in a different video too. Kind of a different topic. So now that we've learned about if statements, there's kind of a cool additional type of if statement that we could use called an if-else. And the reason that we might want to do this is because we can't have a current temperature that is less than the target temperature and equal to the target temperature at the same time. It's either one or the other. But the way that this code is written, we always check this, and then we always check this, because the code just executes top down. So what we could do is use an else block. Because as we gain more experience in coding, we'll find that we want to write the least amount of code possible to get the job done. Because when we have more code, it's more possibility for bugs and logic problems that we didn't consider. And it's just more code to think about and maintain. So rather than having two if statements here, we can trim out that other one and just do this. So now, if the current temp is less than the target temp, we'll print out the heating message. Otherwise, we will print out maintaining. So let's give this guy a run. They're both 400. And we can see that we're maintaining current temperature. If we drop the current temp down to 395 and run that guy, we need to increase temperature. But now we've kind of like, let's say we get up to 500 degrees and we're going to maintain current temperature. Well, that doesn't seem right. We want to decrease the temperature if that is the case. So maybe we need some additional logic here. So let's say we have a string cooling where we are decreasing temperature. And now we need to change our logic here a little bit to take care of this additional step. So I'm just going to move this down a little bit, and we'll do another if-else. So if it's lower, we want to heat. If else if the current temp is greater than the target temp, then we want to system out the cooling message. And then finally, otherwise, we want to do the maintaining one. Code style that up there real quick. So if the current temp is less than the target temp, we'll print out heating. Otherwise, if the current temp is greater than the target temp, we'll do cooling. Otherwise, they must be equal. So now, when we run this, we have our current temp at 500. We would expect to see cooling because we got too hot for some reason. So we'll be decreasing temperature there. And if we're back down to 300 for the current temp, we need to increase temperature. And if we get to 400, then we should maintain the current temperature. So you can see how just by using an additional keyword there, we were able to knock out the actual code block and that whole other if statement, and kind of just do it concisely right here, which is more performant in the long run. So there we go. Well, friends, that wraps up our lesson on an introduction to control flow with if statements, if-else statements, and comparison operators. If you found this content helpful, please like and subscribe to the channel as it really helps me out. And we'll see you in the next one.